Look, folks, we did the experiment yesterday where we found the volume of this prism and then we found the volume of the pyramid. And the pyramid had the same exact base as that prism up above, right? So let me highlight the base down here to just kind of emphasize that this base right here was the same as that one. I know it doesn't maybe look like that in my drawing. The drawing looks like maybe more of a rectangle. So like this drawing right here might look more like a rectangle, but that's really what I'm saying is that this square that's 5.7 by 5.7 is really the same as this one right down here, right? So if I put 5.7 here and 5.7 there, right? Or 5.7 here, maybe where you can see it a little bit better. The area of this square was 5.7 times 5.7. So that's called the base, right? So the base of my object is 5.7 times 5.7, right? So what do we do with that information after we have that? We multiply it by the height. So the height goes right through the middle of the object, right? So from the vertex right down to the middle of the square. That is our height. And it was 9.3 up above, 9.3. So we take, for the volume, we're going to take 1/3 the area of the base. So it's 5.7 times 5.7. And then we're going to multiply that all by the height. Okay, so 9.3. Guys, it's the same formula over here. Let's say we had a height of 9.3. Okay, so let's say this thing had a height of 9.3. And let's say the radius was 5.7. Okay, so the difference though is look at the base. The base over here was 5.7 times 5.7 because that's how you find the area of a square. Area of square. How do we find the area of a circle? See, right over here, the base is a circle. So what's going to change between this one and that one is something like this. The formula over here is pi r squared. And so we go pi times 5.7 times 5.7. I'm going to put parentheses around it instead of a dot because, where's the decimal point? What's the dot mean? So I hope I'm making this clear. Sometimes people think, man, there's a totally different formula between the two. Well, yeah, I mean, if you consider the base having a different formula because the base is a different shape over here, right? It's not a square, it's a circle. So how would the volume look? The volume would be 1/3 area of the base times the height, just like this one. All the pyramids and the cones are going to have the same formula. It's 1/3 area of the base times the height. That's the adjustment that we need to make between a prism and a cylinder and a pyramid and a cone. Okay, so there's an adjustment, and that's that 1/3. That's what we figured out in our experiment yesterday in class. So on this one right here, we're going to go 1/3 pi times 5.7 times 5.7. And then we're going to have it times the height of 9.3. Why is the pi in there on this one? Well, because it's a circle. Okay, I hope I'm making that clear. The same relationship kind of going up here, like if the radius was 5.7 and the height was 9.3, the volume would be, instead of 5.7, 5.7, 9.3, the volume is going to be pi times 5.7 squared, pi r squared. That's what I was saying right down here. I hope I didn't confuse by putting 5.7 twice. It's 5.7 squared. That's the same thing as 5.7 times 5.7, right? And then we're going to multiply that by the height, 9.3. Okay? So on the homework today, we're going to have these two shapes, cylinders and cones, and you've got to just make sure you're using pi r squared for the area of the base, okay? So let's go look at problem number 1. We've added some information to our notes, but maybe you don't have a good example. Well, I think this is a pretty good example right here, but we're going to put down homework problems so you can refer back to them, on the test. So, put this drawing down. I want you to put the video on pause, and then I want you to try problem number 1, then come back and watch some more of the video. All right, thanks for putting the video on pause. Here we go. If you're going like this, pi times, let me just say it one more time. If you're just following along with me, you didn't pause it and you didn't try it on your own, I think this is going to have limited benefit for you. So definitely pause the video. What is the radius right here? The radius equals 6, right? So I'm going to go pi times 6 squared. Okay, let me put that 6 in blue and leave it in blue so it really hopefully stands out to you. So that was pi r squared, right? Pi r squared. And then we're going to multiply that by the height. So we're going to multiply that by 18. All right, so on Desmos, you want to go, 6 squared, that'd be 36. Let's just jam over to Desmos for a second here, okay? So I'm opening it up while you do the same, right? We definitely need to have a Desmos open. And let's see if we can make this a little bit clearer. I'm going to try to leave it tiled if it lets me. Let's minimize this guy. Let's tile it again, and then we'll try to get it on the screen so you can see that, okay? So I want to go pi times 6 squared times 18. So you just type in pi to get a pi down. You could put the 6 right next to it, and then I hit shift 6 to get into the exponent, right? A lot of you guys are experts at this now. So pi 6 squared, and then an arrow to the right. The arrow is right below the shift key, kind of. I'm hitting the right arrow just so I get out of the exponent. And then you just put 18. You don't have to hit a single multiply right there because, this is a number, and Desmos looks at it as, kind of a it's not like I have a 3 there. If I had 3, it would think 36. But because I have a pi there, it thinks, okay, he wants pi times 6 squared. And it's doing the order of operation correctly. It's going 6 squared first, multiplying by pi, then times 18, right? It's got to multiply 6 squared, 6 times 6 first before it multiplies by pi or by 18, right? So here's our answer. How do I write it down? I want to round to the tenths place. Okay, so it's 2035. I wish that would stay on the screen. It won't stay there. And then we got to look right there. See the 7? Well, do I want 7 coming next, or do I want 8? I want an 8 because 52033953 is more than halfway to the next digit. If it was 50000000, then I'm in a pickle. I'm exactly halfway. And so I could choose to go up to 8, or I could go down to 7. And I haven't seen McGraw-Hill do that because it's confusing. Like, should we round up? Should we round down? Some people, I'm not going to get into it, but they've made it so that it's easier to figure out whether we should round up or down. This is above halfway. So I'm going to go 0.8. I'm rounding the 7 up to an 8. All right. Now, what are the units on this thing? Well, we're in inches. That double tick mark means inch. And then down here, I've got IN for inches. So I should have cubic inches for my units. Why does that make sense? Well, I had inches squared right there. And then I have inches over here. So if you take inches squared times inches, that would be inches cubed. Okay. Because you add exponents here in this situation when you're multiplying two bases of the same quantity. I hope I'm making that clear. Here is our answer. I hope you got that answer. Put it in for problem number 1. Put the video on pause, and we're going to try problem number 2 together after you give it a shot, okay? Thanks, folks, for putting the video on pause. Here's what problem number 2 looks like. We have algebra, straight up algebra. And you might say, wait, the drawing is a little different in the program on McGraw-Hill. The height isn't, straight up. Well, it is straight up, but it's not. Like, if I go from the vertex down to the center of the circle, the vertex is directly over the top of the center of the circle, where in the homework problem, the vertex is like over here somewhere. But do you notice they draw the height straight down to the radius in their problem? Well, it doesn't matter. It doesn't affect things if the vertex is dragged to the right a little bit, as long as that height is measuring a perpendicular distance to the base. Okay, so the formula is still 1/3 area of the base times the height. All right, so the base formula in our circles is pi r squared. Now, what is the r? It's x plus 1. So we're going to go pi times x plus 1 squared. That's the area of the base. I'm going to put it right there for the b. So I get 1/3 pi times x plus 1 squared. And then I got to multiply by the height. Well, what's the height? 2x plus 3. So I'm going to put a 2x plus 3 down. Now, guys, this is the answer. This is the volume, but the author might choose to expand or multiply out x plus 1, which is really good practice for our algebra skills. So I got a pi right there. That doesn't really look very neat, does it? Let me try again. I got pi. That's not going anywhere. And then I've got x plus 1 times x plus 1. When you distribute, you got to take the x and you got to multiply it by each one of those terms over there. So when I do that, when I multiply x times x, I get x squared. When I go x times 1, I get an x. Okay? Check mark. I have distributed the x through the x plus 1. Here comes the next thing I have to do. I got to take the 1 and I got to distribute the 1 through both those terms. So I get plus x plus 1, close parenthesis. Now we've got pi times what? X squared. There's some like terms in there. Do you see them? X plus x is 2x's. So I'm going to put 2x. And then I've got a 1 on the end. So I can put plus 1. Woo! So here we go. So now I've got 1/3 pi times x squared plus 2x plus 1. And then all of that's multiplied by 2x plus 3, right? Now here we go. I'm going to distribute the pi through. Well, let me hesitate on distributing the pi through. I've got to take and I got to distribute the 2x through each one of these terms. Man, this is really good for our algebra skills. So be patient with yourself. Be patient with me. I know you might be getting tired at this point. Persevere. You can do it. 2x times 2x is 4x squared. Okay, so let me go back in this one. 2x times x squared. That would mean that I'd have an x times an x times an x. That's how you write x times x times x, x cubed, right? What's the 2 doing there? Well, 2, I can't really multiply it here. It won't, I don't know what x is, so I just leave 2 times x cubed. And then I got 4x squared. That's a 2 right there. Then I got, let's see where I'm at. 2x times 1 is 2x. And then now I got to distribute my 3 through. So let me put a little check mark there. I distributed the 2x through. Now I'm going to distribute the 3 through. The 3 times 1, the 3 times 2x, the 3 times x squared. So I get plus 3x squared plus 6x plus 3. Man, I hope I don't make any mistakes. If I do, you ask me in class, say, what's up with that, Nelson? I don't get what you're doing there. So 1/3 pi. Now we're looking for like terms. Well, there's a 2x cubed right here. I'm going to put a little slash through it. Okay, I don't think there's any other like terms to 2x cubed. I got a 4x squared and a 3x squared. When I add those two together, I get 7x squared. Okay, there we go. We've added those like terms. How about 2x plus 6x? That's 8x. How about, oh, the 3. The 3 is over there still, right? There aren't any like terms for the 3. Woo, man. Hey, this is it. This is the volume formula. But so is this back here. What the heck are we doing? What are we doing to ourselves? Well, if it's, multiple choice, you just have to match it up. Hopefully they got that as a choice. If it's not multiple choice, if it is multiple choice and they don't have that, hopefully they got this right here. If they don't have this and they've distributed the 1/3 pi through all this stuff, boy, I think that's a mistake. But I want you to see if you can match it up. It's not wrong. It just doesn't seem to simplify anything. Like 1/3 of 2 is 2/3, and the pi, well, we can't multiply that anywhere. And then we just have the x cubed. Then I got to take 1/3 times 7. So I get plus 7/3, and I got to take pi times x squared. So you see how this just looks more messy? 1/3 times 8 is 8/3, and pi and an x. And then 1/3 of 3 is 1. Oh, that's kind of nice. And then pi times 1 is pi. So they might have something like that as their answer choices. Honestly, I haven't even looked at their answer choices. But all of these lines are equivalent. That's why I got all these equal signs right out here. Now, the second part of this problem asks you to plug a number in for x. So let's go look at that problem. Oh, shoot, I don't have it open. I don't know. If it says like x is 2, well, you're going to plug 2 everywhere you see an x. So let's pretend like it says, now let x equal 2. Let me say it again. If the next problem after problem 2 doesn't say 2 is x, take whatever number they're telling you to do. I don't remember what it is. So you plug the 2 there. Well, I can look in my book here. Hold on one second. Oh, it says 4. It says 4, I think, on your problem. So let's say x equals 4. You're going to take 4 and plug it in everywhere you see an x, and then evaluate it on Desmos. Hey, thanks for watching my video today. I hope I'm making all that clear.